We've seen our next speaker this morning. He was moderating the panel debate. Luke Briner is a senior software engineer since 2000, now CTO at Pixel Pin Limited, a UK mobile security company. Luke considers quality management to be a key in engineering that's often neglected. Here to talk to us about making the smart decision from the early stages of our architecture, here's Luke.
Oh, it works as well. So anyway, thank you for having me back from this morning. I haven't been escorted off the premises, so hopefully that means it was okay. But I have a very large topic to cover in a fairly short time. I think it's actually less than that. It should be 30 minutes, not 40. If you want me to talk for longer, that's fine. Yeah. So what I want to do here is have a very, very fast kind of journey really from the beginning to the end of building a highly scalable application. Please don't worry that I'm going to be zipping through the slides very quickly. I have too many slides for the amount of time. At the end, there is a link. These slides are available online. There is a QR code and stuff like that. So if you can't read them as quickly as me, they also don't look very nice because I wanted you to have all the kind of the bullet points on there as well. But really, we want to kind of cover these questions roughly in order. Why do we need to scale? You know, what about optimizing performance and architecture? Does that mean we don't need to scale? How do we use the cloud? And a little tiny bit on automation. So hopefully most of you know this kind of picture. The pictures are from Visio, so please don't rate me down for that. But you know, the kind of the simple layout of a web server, you have a web server, you have a database, might be on the same box, might not, doesn't really matter. You have an internet and you have a user. And we know really that the reason that we need to scale is because we have resources and the resources don't last forever. So again, hopefully I'm not teaching you anything particularly new, but at some point, your CPU, your RAM, your network, etc., is going to run out of capacity and your site's going to have a problem. Now, there's lots of reasons for this. The most obvious reason is that if you have lots of requests, you're going to be using lots of CPU, lots of network, etc. But of course, on top of that, you have the issue of the fact that load can be very dynamic. So, for example, one of our customers runs a ticket sales company like Ticketmaster, that kind of thing. And so sometimes when they release tickets for someone like Coldplay, they might suddenly have 10 million people all trying to buy tickets at the same time. So even if your site can handle the average load, it might not be able to handle the peaks. The other issue, of course, about having a single server is about availability. What happens if one of your servers dies? What happens if it reboots? What happens if Windows Update tells you it's only going to take a couple of minutes and 2 hours later the machine's still sitting there configuring? You know, all of these things are going to affect availability. And, you know, the ultimate level of performance, really, we're kind of saying, you know, you might be serving lots of content at the end of the day. You might be serving all of your static assets from your web server and, you know, random stuff that happens like when a VM just suddenly slows down for no reason. You know, all of those things are going to mean that your single server is not going to cut the mustard. So there's some examples there. We don't need to go through all of them, but obviously someone like Amazon, and I'm thinking of Amazon, the shop here, you know, they obviously can't run one server. It's a business critical application. It's a shop. They need it to be up. So clearly they have an availability issue. Someone like Medium, so it's kind of a business, but it might not be considered business critical. If the site went down for 20 minutes, it wouldn't be the end of the world. But actually, because of the high number of users they have, that they're going to need to have some kind of scalable system. And the others, for different reasons, are going to want to scale too. So, of course, one of the first things you might think is, well, I don't really need to scale because actually we can just optimize performance. And I was listening to an interesting talk earlier by Shane over in the web mobile area about performance. And performance means lots of different things. At the end of the day, does the end user perceive that your site is performing well enough. So again, there's all kinds of things here that you can use to make a site appear to load quicker. You can bundle your resources together. You can minify stuff, so making the actual packets themselves smaller. You can do a number of tricks. If you haven't seen it before, I'm just going to quickly show you why slow, which is a plugin. So you've probably seen the network tools in Chrome. You've probably all used them. So you've got some kind of information there, but why slow kind of takes that information really a bit further. You can get why slow for, I think, most major browsers. And what it does is it reloads it. This is from the same website, which is our kind of main www marketing site. And you see that we kind of got a load of A grades there, but that's mostly because it's quite a simple site. But they might kind of say, look, you've got a load of components here that don't have any cache settings in them, so they're not going to be cached, they're going to be requested, or the cache durations are too short. Telling us to use a CDN. We're not going to bother at the minute, but there are tools out there that can basically kind of give you a clue. And the cool thing about why slow is it will explain why these things are good and what they mean. So my first introduction to performance optimization was this plugin, and I kind of go, what on earth is a cookieless domain when it's at home? But it will tell you if you don't know. So we've got why slow. We can kind of optimize performance, but at the end of the day, obviously optimizing will help performance, but it'll only help you go so far. At the end of the day, you can make your site 10 times as good, which means you can have 10 times as many users, but your CPU is still going to run out at some point. Your RAM is still going to run out. And of course, the things like availability, having one server, you can't avoid the availability problem. If that server reboots or if it dies for some reason, then you're going to have downtime, which in a lot of cases is not going to be acceptable. So performance is great. You should be doing it definitely, but... So we then move on to the kind of the idea of, well, how do we optimize architecture? So if we kind of rejig our system a bit and we forget about just having one web server, but we maybe look at some other services, we can actually achieve some really, really big wins. And most importantly, we can get ourselves ready for how we scale up a web application. So the thing to kind of say right from the beginning is, optimizing architecture, it's not rocket science. If I showed you the picture I have on one of my last slides now, some of you would probably break out into a cold sweat and have to go outside for fresh air. It looks complicated, but each individual part of it is fairly straightforward and fairly easy to understand. And really what we end up with is lots of Lego bricks that have been added together, which might look complex, but which can be broken down. And really the foundation for all architecture, certainly for the web, is this idea of scaling out. So you might have heard the phrase scaling up, scaling out. Scaling up means to increase the resources in each of your web servers. Now, obviously on the cloud, that can be quite quick. If you're doing that on your own hardware, then you're going to have to sign a check and buy a load of stuff, and that's going to be pretty slow. But the idea here is we want to scale out. We want to say, can I just throw more web servers at my web application? And if I can do that and keep doing that and keep doing that, and my web application still works, then that's basically what I'm aiming for. So we're involving a load balancer. We'll see a little diagram of what that looks like, but effectively that load balancer's job, they operate at different levels, but the main piece of equipment we're talking about takes in a request and says, I'm going to give it to server number 1 or 2 or 3 or 4 or 5. And there's different ways that can work, but one of the things to kind of understand about a load balancer is you might think having 10 web servers will handle 10 times as many requests as one web server. Unfortunately, that's not actually true for a reason that might seem a bit strange, but it actually makes sense when you think about it, is the load balancer doesn't know how much work each request is going to take. So it can kind of go, yeah, you can have that one. It can do what they call round robin and go one after the other and give it. But what happens if the 10 requests that get sent to server 2 all happen to be really big, greedy requests? Then what happens is that server suddenly starts struggling. The users of that server start seeing a performance hit, and you have a problem. So load balancers are necessary, but it doesn't just multiply out as simply as that. You end up with, like most things, a kind of a natural distribution of what actually happens. One of the main things you'll need to do in architecture right from the beginning is to share session. And I think we'll look at that in a second on the diagram. So one of the first questions you might kind of ask at a very top level, well, how far am I going to need to scale? How much effort should I put in now to make sure my system can handle the right number of users? Obviously, the answer is there is no single answer to that. Clearly, the answer is somewhere between doing nothing and trying to design a system that's going to scale up to Facebook size. Now, if you want to design a system that scales to Facebook, that's great. If your parents happen to be billionaires, you might be able to get away with it. For most of us, that's not going to happen. It will take way too long. We'll be imagining problems that are problems for 5 years' time. You've got bigger problems to fix now. So the answer is somewhere in the middle, and my rule of thumb is, work out what will be a good amount of growth for your company, for this web application, for your product, whatever it is you're doing. What will be a good amount of growth for that in the next year? So for us, we've got authentication as a service. Currently, probably our maximum load might be something like 50 logins per second, which isn't a very large number. A good amount of growth, if let's say we sold to 50 more customers before the middle of next year, that's the company I work for, then maybe that number might go up to somewhere between 500 and 1,000 logins per second on our site. So I can work out as a rule of thumb what kind of architecture I need to make sure that if we get to 1,000, the system can handle it, and even if it's kind of on the edge, I've now got money and time to make some bigger changes. Now, our system is quite simple, and we could probably scale a lot bigger than that, just because it's not doing very much work for each login. The link down there is a very interesting story. I recommend you read it. You don't need to write it down now. You can zap the notes later on. That is a story about Obamacare. So who knows what Obamacare is? Or it's called Obamacare. So it was basically the USA saying that it's about time that people in the USA had access to an amount of free healthcare. So like in Europe, we forget that not everybody has free healthcare all the time. So it was a great idea, but how do you design a system that's going to be used by millions and millions of different people? And the answer is, well, they didn't really design it very well to scale. And the story there is a story of how it was a bit of a disaster. It got released. The pages were taking 10 minutes to load. They said, I can't remember what the statistics are. They're on my notes somewhere, but something like 80% of the people who went onto the site didn't manage to get to the end of the application process. And out of the 20% who did, only 5% of those actually managed to pay or to apply for the thing. So it was kind of a disaster, but it was something that could have been foreseen. And the guys who came along, not to jump too far ahead in the talk, ended up using Amazon Web Services and a number of other kind of tricks to make that better. So, it does happen. People do get it wrong. In that case, it was very public. And in most cases, it's not quite as bad as that. But, they could have foreseen that. They could have designed for it. And they could have ended up with the system that they eventually got if they would have spent more time. So the basic scaling architecture, again, you might have seen this kind of thing before. You have a load balancer. If you have a load balancer in your data center, it's basically just looks like a little server. And usually that can handle a very high number of connections at the same time. And all that load balancer's job is to say, here's a request, I'm going to give it to one of my other servers. So sometimes you might have a rack with maybe 10 web servers or 10 virtual machines running maybe 100 web servers and one load balancer to basically manage all of those. So that's the basic system. The shared session, I've talked about it before, but if you think about it, if you've ever worked with a session in a web application, you know that it's important that if I, as a user, go back to a different server, that other server knows what I was doing. So it's no good adding stuff to a shopping cart in Amazon, and then all of a sudden my request goes to a different web server, and it kind of goes, well, who are you? You got an empty cart, the systems need to be able to communicate with each other. You can use the database to do that. As you can see, the database here is a common component, but that can add performance overhead, significant performance overhead to the storage of sessions. So it's very common. What we do is we use Redis, which is just an in-memory store. And although they're kind of single point of failures, there are actually ways to work around that, to have failover, to use cloud services that have all of that resilience built in. But effectively, the shared session is the first step that you need to make towards load balancers. Now, I'm going to dance through these very quickly because, again, I could take a whole conference talking about database scaling. This is something that often becomes a real pain for architects, for system architects, especially if you're trying to take an existing application that makes heavy use of databases and try and make it scalable. You will find that you will be able to scale out so far, and then all of a sudden the database will become the problem, and having a single database won't work. You know, all distributed databases, however you do it, you're going to start trading off performance and consistency. If you want it to be fast, you can't wait for all of your database replicas to update. But if you want it to be consistent, you might have to take a performance hit. And that could be significant. That could be, 2, 3, 4, 5 seconds. And for most applications, you can't have somebody waiting that long. So you want to put this off as long as possible. If you can not scale your database or not need to scale it, then that's good. But we've got kind of, that's a single database model. You can see it's a performance bottleneck, especially, there's 3 web servers, but the ticketing customer we have, they scale up to 2,000-3,000 web servers when they're selling tickets to a big concert. So we're talking about a lot of web servers. Imagine they're all trying to make a connection to the same database. You can imagine it's not going to be pretty. So you could have, multiple databases. You could say, well, I've got a database on one side, I've got a database on the other, and I kind of just use whatever. But, the problem with here is, well, how do we do this? How do we make that data consistent? We could perhaps split it up and say, well, the data about tickets is in one of them, and the data about payments is in another. Great if your system works like that, but most of us, we have one main data set, and that's usually the problem. So we can't usually just split it into 2. We can have a single database with a failover. So again, we get availability here in case the main database falls over. We don't really increase the performance. The reason this is over here is because it's a tall picture. We can have a single master and multiple read-only databases. Now, this is a very useful pattern if your application reads a lot more than it writes. So we use this at Pixelpin. These read-only replicas could be all over the world, but the single master still becomes a bottleneck for your writing. So again, if your application writes a lot, you can end up in trouble. And then the one with the dragons there is, having more than one database that you write to. So writing to more than one database introduces something called a conflict, or potentially something called a conflict. What happens if I update a record in Japan, somebody updates the same record in America at the same time? At some point, those 2 records are going to meet in the middle and go, what do I do? Now, again, for your application, there might be an easy answer. The easy answer might be we just take the most recent update. That might be okay. It might not. We might say we have very, very fine-grained transactions with special, globally unique identifiers. So you might be able to automate it. You might get away with it, but it might also be a complete pain in the neck. So try and avoid this if you can. That's why it says gulp, which means... So this is something I discovered late on in life. As you can see, I'm kind of slightly elderly. The grey hairs are showing. And when I was a kid, we didn't have, these cool things like NoSQL. We had something called SQL. All databases pretty much were SQL, or they pretended to be. And, the thing with NoSQL is it can be an amazing tool if you can make your architecture decisions with this in mind. So we're currently in the process of rewriting our application to use NoSQL. We didn't have to do very much work, but we will have to migrate our data from SQL Server to NoSQL. But the idea of using NoSQL is if we can break these relationships between all these different tables, we can start almost putting what you might consider a table in its own little set of data. So on that disk, I'm going to have my users. On this disk, I'm going to have my clients. On this disk, I'm going to have my payments, or even some users on here, some users on here, some users on here. So of course, I can scale that out, really, really far. So if it was done wrong, I would end up still having to go to every one of those data stores and say, do you have my data? No. Well, do you have it? No. Do you have it? No. Do you have it? Yes, hopefully. But you would have to search all of them to find out that you didn't have the data, and at best you'd be getting 50%. But if we choose our partitioning correctly, and again, please ask me questions about this later because we definitely don't have time to go into details, but if I partition, let's say, user information based on age, assuming that that's quite a nice balance of data, then as long as my query has age in it, then the system will know which of my data shards to go to in order to find that data very quickly. So it says, well, I know that age 20 would be in shard 2, so I don't need to ask the other shards. I can ask shard 2. If it's not there, then it's not anywhere. So there's some stuff there that we can go into. RAM cache, again, hopefully all of you use this on your sites. RAM is fast, is relatively expensive, but actually it's an easy way of adding performance to your site. So rather than going back to the database 10 times during a user journey to get the user data, why don't I just go once, cache it for 30 seconds, it's not going to change in 30 seconds, and I get it out of memory. And basically you're showing your databases the love. Because, we live in a modern world, we show love to everybody, including databases, because they're people too. I've kind of already mentioned this, I'm not going to go into it again too much. With all architectural decisions, especially when we scale out globally, we have to ask this question, how much consistency can I live with? How much performance do I need? There's always going to be a minimum level of performance that we're going to want, but at some point we're going to say, can I accept data that might be slightly out of date? If I go to my Facebook feed and it hasn't got that update that my friend made 10 seconds ago, who cares? It will come up eventually. I can live with that. If we wanted all of the Facebook to everything to be synchronized at the same time, then every update we make would take about a minute and a half. So, we can look at that, we can ask questions on that again. Measure everything, we've probably said it 100 times today. As these things start happening, as you start rolling out these ideas, measure stuff. And the main reason is, apart from the obvious reason, the main reason is sometimes things don't do what you think they're doing. So we had a system once, and I was trying to do some performance testing. I wondered how much network was going between these two servers. And in my mind, I thought, well, I know how much data is being sent, so I would imagine the total amount of data might be something like, let's say, 1 megabyte. So I look at these network logs, and network logs show it's like 100 megabytes. I'm thinking, how on earth is it 100 megabytes? Well, the first answer was I never actually found out because I didn't look into it long enough. But the point is, there was a problem there that I didn't understand well enough. So I can throw optimizations at things and make stuff better, but if I'm not measuring the outcome of it and finding that it is actually doing what I think it's doing, then it's not going to work. People have found bugs in processor cores. They found bugs in software frameworks just by actually being able to measure and go, hang on a sec, that's not right. It should be less than that or more than that. So make sure you measure everything. Performance testing is hard, but, and the last question is one I think that's, last question on this slide, don't get too excited, is do you know how far your system can scale before you're going to have a major architecture headache? So for ours, I'll show you the diagram later of roughly how our architecture looks. I could scale up probably Azure NoSQL database. We use Azure, please don't mark me down for that. We use NoSQL or Cosmos DB, and that can scale out pretty much to as deep as your pockets are, however much cache you've got, you can have that bigger. We can scale out to probably 100 app service environments all running 50 instances. So I think we can scale quite a long way, but if I can't answer that question, then I have the danger that one day someone's going to ring up and say, why has your site started slowing down? And I'm going to go, oh crap, what am I going to do now? Because architecture changes can take a long time, so we need to be trying measuring it. Right, I've got a few minutes left. The cloud, that is not the actual cloud. That's just a picture of a random one I found online. But I just want to go, let's dance through these again. What is the cloud? We're talking about, for me anyway, services that are abstracted. So I don't want to deal with a virtual machine running Redis. I want to deal with Redis. So if I can just have a connection string and just fire it and forget it and let Microsoft or Amazon or Rackspace or somebody worry about that, then that's great. I can worry about the things that I understand. Services that are optimized. Pay as you use, fantastic. That is for saving cash. Quick and easy to spin stuff up. Traditionally, if you don't use the cloud and you want to do something on a 64 core machine, you might have to spend 20 grand to buy it in, and that's going to take you 6 months. You can run it on Amazon for 20 minutes and pay $5 or something. So why not? What it is not. So the cloud isn't just another name for outsourcing your data center like they used to do in the old days. It's much more than that. And the cloud isn't one thing. I put at the bottom, the cloud isn't Amazon Web Services, because I think some media outlets think it's the same thing. People have cloud. It's not infrastructure as a service. So even though you might have infrastructure as a service on the cloud, IaaS doesn't make a cloud. So let's just do that. You probably already know why it works for companies. You can read these afterwards yourself. The total cost of ownership is generally lower, certainly when you're a small company. The only reason people like Facebook and Google eventually leave the cloud is when you're looking at specialized systems, specialized performance optimizations for your type of traffic and your type of company, and you've got several $100 billion in the bank, then you can afford to do that. For most companies running dynamic workloads, the cloud is going to cost you less. So here's a couple of very, very rough comparisons. So this is cloud versus on-premises. One of the things that you don't think of when you're comparing prices is, what about maintenance staff? What about equipment costs? What about backup generators? What about testing the backup generators and having them serviced? What about the aircon? How many air cons do I need? Has anyone ever bought an air con for a big room? It's well expensive. All of those things that you kind of get included in the cloud. So although your monthly rental might be $3,000, which is more than it might cost you in electricity to run your own data center, by the time you factor in everything else, again, very rough number at the bottom for on-prem, similar for outsourced data center. You're saving some money because they're providing the building for you, etc. But you probably need some of your own staff. Do you need 24/7 support cover? All of those things. So it can end up saving you significantly. Things to look out for in terms of choosing a cloud provider or even going to the cloud generally. Be careful that there are certain service abstractions. By definition, if you're going to use, service Redis, it's going to look a certain way on AWS that's not going to be the same as Azure. It might not be a difference that's a problem for you, for your application, but it might be. So as if you decide to move between cloud vendors, it's not always as easy as you'd like it to be. There's obviously a control issue. You can't control how they do stuff and what they do. So if you need ISO 27001, you can't just walk into their data center and do the audit. You'd need to trust their certification. So and be careful with pricing models. This is one example. It's a bit of an out-of-date example, but if you use Redis for session, you have a fixed amount, it's 87 euros a month currently. What happens if you use Cosmos DB, which is NoSQL? Well, then you're actually paying for your usage. So the actual monthly cost is very small, 21 cents a month. But, at the basic level, it's only 20 euros a month. Well, that's great. But if you start using a lot of session data, all of a sudden it might be 80 euros or 160 euros or end up costing more than Redis. So beware that the pricing models for different services are different. Some reasons why it might not work for you, but you can read those later. And this is a very simplified version of what we have at Pixelpin. So none of those things individually are complicated. It looks complicated, but it isn't really. We have a data center in Japan. We have one in Ireland. All of this stuff we can spin up very, very quickly. So using as your resource manager, if I want a new environment for, say, performance testing, I can get it up and running in about 10 or 15 minutes, which is about how long it takes Azure to get Redis ready for some reason. But spinning stuff up, I can automate all of that. Which is kind of one of the main powers of using the cloud for this, talking on the DevOps stage, or the devil's stage, as my predictive text said earlier. which is a bit worrying. And I couldn't even change it back. It's like devil, 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 no, DevOps, DevOps. But you know, we can, when I say support most languages, I'm talking about programming languages, but you can automate all of this from your Jenkins and your Puppets and your Chef and your PowerShell and your Bash and your Shell and whatever else you like. So, you know, this is really cool for automating, for measuring, for monitoring. All of this can come from APIs, which makes it much, much easier than trying to install all of that on your own data centers. Examples of things that are, you know, as your resource manager, great, but. So everything's got a pro and a con. You need to do your AWS identity management. Yeah, it's great, but, you know, it's poor user interface and it's hard to debug and stuff like that. So for everything you look at, every service you look at, every provider you look at, you're going to have pros and cons. So unless you have something very, very simple, you know, you should design to scale. Even if you think you'll never have more than 1,000 users, if there's any chance that you're going to end up with 5,000 or more users, then design it to scale. It's not much work. You don't have to scale it out, but if you can support more than one server, you'll be laughing. You know, somebody needs to do the homework and do, you know, study the architecture, understand some of these things, but that's pretty straightforward. Probably said all the rest of it. You know, if you become as big as Facebook and say, none of this works because I'm as big as Facebook, you certainly won't be coming to me for advice. And you're welcome to build your own data centers and scale out to 400 million servers or however many they have. So, 1 minute to go. There might be lots of questions, which I'm more than happy. I'll hang outside for a bit afterwards. Some answers to questions are quite long, and we don't have very much time. Have we got anything on the app? Do we know?
Let's check. I feel you were like a runner.
Like a runner,
yeah,
sprinter.
Here's a bottle of water.
Oh, great. Thank you very much. Ooh. So, say the amount of time it takes me to bring up the app. It might...
Yeah. I don't see anything
no,
on the
no questions there.
So if
we've got time for one question now, otherwise we'll go outside. And like I say, there's a QR code, hopefully it will work, which is the slides. By all means, read them. You've got my details there if you want to, whatever you do, ping, tweet, and contact me and ask me questions. But otherwise, thank you very much.
Thank you very much.